Hello everyone, today we'll talk about a solution to the problem minimum array end. Since we want the end of the final array, the bitwise end, to be equal to exactly x, then what do we know about the numbers in our array? Well, assuming that the bitwise representation of x looks something like this, then every number in our array has to have ones in all the positions where x has ones. Because otherwise the bitwise end of the whole array will not be equal to x. If there is any 0 at any position where x has a 1, then the bitwise end of the array will not have a 1 at that position, which is bad. However, we probably also want to make sure that all the values in our array on every other position, at least one of those values has a 0. Some of them can have 1s, but at least one has to have a 0. And that's one way that we might think about it, but it's probably not the best way, because when looking again at the fact that all of our numbers have to have ones at those positions, and we want to have our array be, well, we want it to be increasing, and we want the final number to be as small as possible, then if we can take, let's say, the first element of the array and make it smaller, then it doesn't change anything, it doesn't make anything worse, and the smallest number that has ones on all the positions where x has ones is exactly x. Okay, so we know that x is okay for us to have in our array, but if it is the first element, and we've noticed that it can be the first element, it doesn't destroy any solution, then we are sure that the final end of the array cannot be anything greater than x. Right? So if we start with this x, then that is the maximum bitwise end that we can ever get, because all the other positions at x are equal to 0 in this first value. So we know that we will be starting at x, and we want to get now the smallest final number that this array can have. And probably the most convenient way of looking at it is that we have those question marks here, we have those slots where we don't know what should go there, and we want the numbers to be ever greater and greater, such that the final one is as small as possible. And we know that if, let's say, x is equal to 0, then we can just take 0, then we can take 1, then we can take 2, then we can take 3, 4, it's of course binary. Those will be the numbers in such a way that the last one is the smallest for the number of numbers that we have, just consecutive numbers. And since here we have literally no way of changing those ones, every number has to have those ones, then we can just forget for a second about those positions, only look at those question marks. And for those question marks, the process is exactly the same. We want the first number to have all zeros, the next number to have a 1 here and the rest zeros, then we want to have 1 0, then we want to have 1 1, and so on. And the final number then, since it has to be the n minus first number in the array, will have the number n minus 1 spelled out in binary on those question mark positions, and the positions of x will be set to 1. And this is the solution that we'll be doing. It's probably possible to do it in a shorter way, maybe with some bit manipulation, but my solution just does it in a straightforward manner. So we'll be keeping the bits of our number, creating it from the least significant bits forward. The value that we have on those question marks will be n minus 1, so we have to subtract 1 from n at the beginning. And we have to make sure that we go through both every bit in n minus 1 and every bit in x, so that the final value is correct. So while there remain any bits in n or x, we have to make a decision at first whether or not this is a question mark position or a forced 1 position. So this would be a question mark position. So this would be a question mark position because the value has 0 here. X has 0 at this position. If x had 1, then this is a forced place where we have to have a 1. So we look at x, at the least significant bit of x, so just x binary ended with 1. If that is indeed true, so if this is equal to 1, if this bit is set, then we know that we have to append 1 to our final value. And of course, whatever we do, we have to shift x by 1 to the right. We have to discard the least significant bit of x, because we've looked at that bit. So in that case we append 1, otherwise we have a 0, which means that this is a question mark position, so we have to take the appropriate least significant bit remaining from n-1, so we again append the least significant bit of n-1, and we shift the value one step to the right, the same as we do with x. So at every step we eat the least significant bit of x, and if this is a question mark position, we also take the least significant bit of n to put at that slot. At the end we have to convert this list of bits starting from the least significant bit into an integer. So this will be an integer in base 2 of a string. This string will be the concatenation of the values in our list. So we have to join and we have to join. The list has to be reversed because the least significant bit should be the last for the conversion. And of course here we have just zeros and ones, so we have to first transform them into strings. So we map string over the reversed bit list. We create a string from it by just joining it with an empty string, convert it to an int with base 2, and this is the value that we finally return.